Okay, this video is for Calc 3, and it's section 15.5, specifically number 30 in our textbook homework. So we have a lamp that has two bulbs of a type with an average life of 1,200 hours. So the bulb, on average, from testing, we found lasts about 1,200 hours. And we can model the life of that bulb with an exponential density function. And that exponential density function, of course, then has a mean of mu equals 1,200 hours. So the average lifetime is 1,200, so that means the mean is 1,200 hours. So find the probability that both of the lamp's bulbs will fail within 1,100 hours. So the lamp has two bulbs. Both bulbs are on burning at the same time. And we want to understand if it's going to burn out before 1,100 hours. So below average, right? Below average. So we set up a probability function in terms of x and y. I've got two bulbs. So bulb 1 I'm going to call the x bulb, and bulb 2 I'm going to call the y bulb. So the density, exponential density function is this: 1 over mu times e to the negative x divided by mu. That's my density function. Okay, so I can fill in that function specifically with our problem here, right? So I have 1 over 1,200, because that's my mu, and then e to the negative x divided by the mu. So that's my function if x is bigger than or equal to 0. So as time, hours, x gets bigger, it's described by this function. As it gets bigger than 0, when time is before 0 or before the light gets turned on, we plug in a 0. And the same exact idea for y. The bulbs are the same, so my y bulb has the same parameters. If I had a different type of bulb, I would put in a different situation here, but it's the same bulb. So it's the same, except for now we're talking about the second bulb, which is the y, and then 1 to 0, 0 life hours. Okay, so that's my function, and of course if y is bigger than or equal to 0. Okay, so I put those two things together. I've got my my x and y put together, and because they're running on the same system, either consecutively or at the same time, so this is the general x multiplied by y together, and then I worked all that out with the x's and y's. So you combine the 1 over mu, so you get 1 over mu squared, and then you're multiplying e to a raised and e to a raised, so I can write that as e to the 2 added together, the two parts that are raised, and then so I get this exponent of negative the quantity x plus y all divided by 12. Okay, so then for part A, those bulbs are running together, right? So I'm going to set up that integral, the probability of x and y together, both being less than or equal to 1,100 hours. So I have a double integral. I chose to do it in the order of y first and then x. I could do the other way around if I wanted to. I just chose y first and then x. And so the y part is running from 0 to 1,100. And then I put in my function. I have to evaluate that. And once I figure that out, then I do the x part, which is also running from 0 to 1,100. And our problem asks us to round that to 4 decimal places. So then part B is a different lamp, right? So another lamp has one bulb, so one bulb burning at a time, but the parameters of that bulb are the same as in part A, which means their average life was this mean of 1,200, and they follow this exponential density function. So the bulbs are the same, but they're only running one at a time. So if one of the bulbs burned out and then is replaced, find the probability that the two bulbs fail within a total of 1,100 hours. Okay, so one bulb burns, it burns out, you take out that bulb, throw it away, and put in exactly the same type of bulb. And we're asking, in that process, what happens, and what's the probability that that will burn for less than 1100 hours. So in this case, we have the probability of x plus y. So we're adding x to y, and that's less than or equal to 1100. All right, so now I've drawn a picture of what we're talking about here. This is x plus y together, and if I solve that for y, I would get y is equal to 1100 minus x, and I've drawn a picture of that, right? That's what this is. And so the area that we are integrating over in three-dimensional space is this triangle that's less than or equal to that y equals 1100 minus x. All right, so then I can set up the same exact integral, and I set that up as that's equal to the double integral from, oh, I gotta delete this part. The double integral from some bounds to some bounds of 1 over 1200 squared times e to the negative x plus y divided by 1200. And then I'm going to set it up with dy dx is how I'm going to set it up. So the dx is on the outside, and if I set it up that way, I would have from 0 to 1100, and the dy is on the inside, and then my change in y then would be this, right? So it would be from 0 to 1100 minus x. And then I just need to evaluate that iterated integral. And our question asks us to do that to 4 decimal places. Now, one thing I want to point out is in both of these situations, the bulb was the same, right? Bulb A and bulb B are the same. But if we have the situation where bulb A was different than bulb B, when we combine them together, the mathematics would look a little different, right? So this would be bulb A, this would be bulb B. So the values wouldn't necessarily be this 1 over 12 squared or 1 over mu squared because the mu's may be different. The top here might be slightly different because we're combining 2 different things, so the multiplication might be more complicated. So just be careful of that. In this particular example, the question was the bulbs were identical, so we can have a little bit easier time of the algebra.